Howdy, and welcome to the Intelligent Child search engine demonstration video. The students who have worked on this project are Wyatt Masterson, Emmeline Blevins, Samyam Pandey, Prakar Singh, and David McDonald. We're very excited to present our implementation of this technology. First, a brief introduction into what this system entails. Intelligent Child, or the Community Health Information Local Database, is sponsored by the TAMU College of Health and seeks to connect young families, mothers, or kids with relevant and vetted community and healthcare resources. The team for the past semester is focused on implementing the search algorithm to process a user's natural language inputs. Currently, traditional search engines can be troublesome when seeking out local community and healthcare resources. The millions of results may appear overwhelming, and the trustworthiness of some results may also be called into question. Also, it can be difficult to search for medical resources when you aren't familiar with medical terminology. Next, onto the implementation. The application was built with a Python and Flask backend, utilizing a NoSQL Mongo database and the Esperant language model for natural language processing. Here we have two architecture diagrams for our system. On the left, we see how the backend is able to encode the database resources into a usable format for our language model. On the right, we see how a user's search query is processed and compared to the encoded database resources in order to return the most relevant ones to the user. Next, we have a quick demonstration of the hosted application. First, I'll type in a query seeking prenatal resources, which returns a list of 5 organizations which would help the user in their specific scenario. For our next query, we can type in, "How can I start saving money?" Notice that the website only returns one resource, as the Brazos Valley Financial Fitness Center was the only one that registered a high enough confidence score to be returned to the user. Of course, typing in a nonsensical query will not return any results. Let's move on to how we evaluated our system. Through internal unit and integration tests, we ensured that our code was robust and correct without bugs. Because we are potentially dealing with real changes to maternal or familial health outcomes, we needed to ensure the iChild system always works as intended. User acceptance testing allowed us to ensure compliance with the TAMU College of Health. More than 20 participants tested the system during 2 separate rounds, allowing us to gather data about queries and determine if our search engine was returning relevant results. Using Likert scale questions, we were able to quantify this data and show improvements between the first and second rounds of testing. Thank you all for learning about the new Intelligent Child system, and look forward to additional future work.